Hi, my name is Kistina Uzma binti Zul Hisham.
Hi, my name is Tamia Shafini binti Marzuki.
So today I'm going to explain the question number 1. So the question number 1 is, consider an experiment of tossing 2 coins and rolling a dice simultaneously. Let X denotes the total number of heads and Y the number that came out on the die. A. Construct the joint probability distribution table of X and Y. So for the first step, we are going to list out for all possible outcomes. Let tossing 2 coins as TT, TH, HT and HH, and then rolling a dice as 1, 2, 3, 4, 5 and 6. Next, we are going to list the sample space. The total of sample space required is 21. Okay, next, let X be the total number of heads and Y the number that came out on the die. And then the number of outcome for none X and Y are picked at random is 1/24. Okay, so next we can construct the joint probability distribution table of X and Y with 1/24. Okay, for the B, find the marginal distribution of X and Y. So let X and Y be discrete random variable and fxy is the joint probability function. So the marginal distribution of X is fx equal to fxy all Y, and the marginal distribution of Y is fy fxy all X. Okay, so next for the marginal distribution, we can just use the table from the joint probability distribution and adding another column and row for fx and fy. So for the 0, we can just use we add on 1/24, 1/24, 1/24, 1/24, 1/24, and that becomes a 1/4. Same goes to the other one. And then for fy, we add on 1/24, 2/24 and 1/24 and get 1/6. Okay, for the next question C, determine whether X and Y are independent. So we just use the formula which is fxy equal to fx multiply fy. So for f01 is equal to 1/24, f0 is equal to 1/4, f20 is equal to 1/6. So f00 is equal to f0 multiply f20. So it will get 1/24 equal to 1/4 multiplied with 1/6. Hence, Y and X are independent. So the last question for question 1 is D, is determine the mean and variance of W equal to 4X minus 3Y plus 5. So first thing first, we are going to find out mean. So mean, we are going to find EX and EY. So for EX, 0 multiply with 1/4 plus 1 multiply with 1/2 plus 2 multiply with 1/4 is equal to 1. And then EY, 1/6 multiply with 1 plus 2 plus 3 plus 4 plus 5 and plus 6 is equal to 3.5. Next, EW is equal to 4EX minus 3EY plus 5. So we are going to substitute EX and EY. So we'll get 4 multiply 1 minus 3 multiply 3.5 plus 5 is equal to negative 1/5. Okay, next we are going to find the variance. So var x is equal to e of x squared minus the square of e of x. So ex squared is equal to 0 squared multiplied with 1/4 plus 1 squared multiplied with 1/2 plus 2 squared multiplied with 1/4 is equal to 1.5. And then for var x is equal to 1.5 minus 1 squared equal to 0.5. Next, for var y is equal to e of y squared minus the square of e of y. So for ey squared is equal to 1/6 multiply with 1 square plus 2 square plus 3 square plus 4 square plus 5 square and 6 squared is equal to 91 over 6. So for var y equal to 91 over 6 minus 3.5 squared is equal to 25 over 12. So to find out for var w is equal to 16 var x plus 9 var y. So we are going to substitute the var x and var y. So it's going to be 16 multiplied with 0.5 plus 9 multiplied with 35 over 12 is equal to 34.25.
Next, I'm going to explain about question 2. Let the joint probability density function of y1 and y2. The function is 4y1 power of 3y2 plus y2, where y1 is more than or equal to 0 and less than or equal to 1, where y2 is more than or equal to 0 and less than or equal to 4. To find the value of k in question A, we use the property that the total probability of a joint probability density function PDF must equal to 1. We integrate the given PDF f y1 y2 equal to 4y1 power of 3y2 plus y2 over the entire range of y1 from 0 to 1 and y2 from 0 to k. First integrating with respect to y1 give 2y2. Then integrating with respect to y2 give k power of 2. Setting this equal to 1, we solve k to equal to 1, which give k equal to 1. To find the marginal density function of y1 and y2, we integrate the joint probability density function fy1 y2 over the other variable. For the marginal density of y1, we integrate fy1 y2 equal to 4y1 power of 3y2 plus y2 with respect to y2 over its range, y2 more than or equal to 0 and less than or equal to 1. After the integration, we will get 2y1 power of 3 plus y1 over 2. To find the marginal density function of y2, we integrate the joint probability density function over the other variable, which is respect to y1. With the same range, which is y1 more than or equal to 0, y1 is less than or equal to 1. After the integration, we will get 2y2. For question C, to determine whether y1 and y2 are independent, we need to check if their joint probability density function can be written as the product of their marginal density. From earlier, we know that fy1 y equal to 2y1 power of 3 plus 1 over 2 and fy2 equal to y2. Multiplying these two marginal density give the same expression as the joint PDF. Since the joint PDF equal to the product of the marginal, y1 and y2 are independent. For question D, the task involves finding the conditional probability y1 more than 1 over 4 and less than 1 over 2 if y2 equal to 1 over 2. The first step we need to do is find the joint probability when y2 equal to 1 over 2. Then the marginal distribution y2 equal to 1 over 2 is calculated by integrating over all possible y1. Using the conditional probability formula, the integral of fy1 y2 function y1 y2 equal to 1 over 2 over y1 more than 1 over 4 less than 1 over 2 is normalized by y2 equal to 1 over 2, and we can get 79 over 512. For question E, the goal is to calculate the expectation value of P, where P equal to 5y1 minus 2y2 plus 8. Using the linearity of expectation, we can write this down as EP equal to 5EY1 minus 2EY1 plus 8. First of all, we need to calculate the EY1 by integrating y1 times the marginal y1 over the range of y1, where the marginal y1 equal to 2y1 power of 3 plus 1 over 2. Solving this integral gives us EY1 equal to 13 over 20. Finally, we need to substitute the value into the equation for EP, then we can get 199 over 20.
That's it. Thank you.